Hello, this is Miss Leva, and for our second part of our video today, we're going to be going into the real-world application for similar figures. So we're going to go ahead and jump straight into some examples. So example number 3, Juan is enlarging a photograph whose length is 12 inches and the width is 10 inches. If the length of the new photograph will be 39 inches, what will the new width be? So anytime that I have a word problem like this, the first thing I like to do is I like to draw a picture if one was not given to me. So I'm going to go ahead and draw what they're talking about. So he's enlarging a photograph, so it's basically a picture, and I know that pictures are typically in a rectangular shape. So I'm going to draw the original picture. So the original picture had a length which was 12 and a width which was 10. So I know that 12 is a bigger number, so I'm going to put that on my bigger side. And the width is 10, so I'm going to put that on the shorter side. So my length is 12 and my width is 10. So 12 is L and 10 is W. And they're telling me that he is going to enlarge this photograph. So enlarge means that he is going to make this picture bigger. So I'm going to draw myself a rectangle that is bigger, which is going to represent the new picture. And for these new photographs, the only thing I know is that the length will be 39 inches. So because the length was here, the corresponding length would have to be here. So 39 inches would be equal to my length here. And then what is the new width going to be? So I'm trying to figure out what measurement belongs here. So I've got my picture. So now I can go ahead and start setting up my proportion just like I've done before using my 4 labels. So for my 4 labels, I'm going to use original, new, length, and width. And remember, your labels are interchangeable, so you can put them in different places. So I'm going to put length and width up here. And then I'm going to use original and new on the side. So I'm going to go ahead and start filling in what I know about these numbers. So what is the length of my original picture? The length of the original picture is 12 inches. What about the width for the original picture? Well, the width was 10 inches. And now the length of my new picture is 39 inches. And what about the width for the new picture? Well, that's what we don't know, so I'm going to use the variable x to represent the width. So now I have my proportion set up. 12 over 39 equals 10 over x. So remember, with proportions, we do have several different ways that we can solve it. One of them is that if we can simplify, we should try to simplify the ratio that was given to us. So I'm looking at the ratio that I have, 12 over 39, and I think that I could simplify that before I start solving it out. Because 12 and 39 are both divisible by 3. So I can divide by 3, divide by 3. So 12 divided by 3 will give us 4. And then 39 divided by 3 will give you 13. So my new fraction, or my new ratio, is 4 over 13. So I no longer have the 12 over 39. I have simplified that down. And so I know that the proportion does look a little cluttered right here. So what I like to do once I've simplified that out is I just like to rewrite it on this side. So equals 4 over 13. So this is the proportion that we are working with right now. And again, I just moved this ratio over here to the side just so that it doesn't look like so much going on at the same time and I don't get confused with some of the older numbers that were there. So my new proportion, 10 over x equals 4 over 13. So now I need to try to figure out if I can work either within or between these numbers. So remember, you always want to work towards your variable because you're trying to figure out what the x is. So I can either try to come from 4 down to 13 or from 4 across to 10. So I think it's going to be easier to get from 4 to 10. And if you ever don't know how to get across, you could take 2 numbers that are given to you and you can divide them out to try to figure out what scale factor they used. So if you take your calculator, you divide 10 divided by 4, it should give you 2.5. So what that means is that I took 4 and I multiplied it by 2.5 to give me 10. So remember, with the proportions, whatever you do to the top, you must also do it to the bottom. So to get our solution, we just need to multiply 13 times 2.5. So I'm going to go ahead and put that into my calculator, 13 times 2.5, and that gave me 32.5. So I know that x is equal to 32.5 inches. And so what that's telling me is that the new width for this photograph will be 32.5 inches. So the new width is 32.5 inches. So moving on to example number 4. So George is drawing a triangle similar to the one below. The length of the longest side of the new triangle is 9 inches. What are the lengths of the other two sides of the new triangle? So he's drawing a triangle similar to the one below, so I know I'm working with similar figures. The length of the longest side of the new triangle is 9 inches. So the longest side for the new one is 9 inches. So I'm going to come over here and I'm going to look at what is the longest side for the original image. Well, I know that 15 is my biggest number, so that means this was my longest side originally. And they're telling me the new longest side is now 9 inches. So what happened to the triangle? If it was 15 inches for the longest side, now it's 9 inches. Did he make the shape bigger or smaller? Well, 15 compared to 9, it looks like he shrank the shape. He made it smaller. So I'm going to draw my similar triangle a little bit smaller. And the only thing I know about this new triangle right now is that the longest side is 9 inches. So this was my longest side, my hypotenuse. So this is my corresponding longest side. And I know that this one is 9 inches. So what are the lengths of the other two sides of the triangle? So I don't know this side and I don't know this side. But what I'm going to do is I'm going to take what I do know and I'm going to try to figure out what scale factor did he use to get from the original to the new. So that was the original and that's the new one. So I need to figure out what did he multiply by 15 times something to give him 9. So remember we can set up the ratio to find the scale factor, which is new over original. And the only side I know is the hypotenuse, the longest side. So the new one is 9 inches. The original was 15 inches. And so remember when you set up your ratios, I told you if you can simplify, go back and simplify to make them smaller numbers. So I know that they're both divisible by 3, which will give me 3 out of 5. So this 3 out of 5 is the scale factor that George used to create this new triangle. So he's using a scale factor of 3/5. And so remember in the first video I told you for scale factor what you can do is just take the original number and multiply it by the scale factor to get the new value. So we're going to do that with a 10. So 10 times the scale factor of 3/5. So I need to turn the 10 into a fraction by putting it over 1 times the scale factor of 3/5. So fractions just multiply straight across. 10 times 3 is 30. 1 times 5 is 5. I get an improper fraction, which just means to divide. 30 divided by 5 equals 6. So it looks like this part here, which corresponds with this part here, will be equal to 6 inches using the scale factor of 3 over 5, or 3/5. So this part is 6 inches. And then another thing that I like to do sometimes when I have scale factors like this is if I don't want to necessarily multiply with fractions like this, another thing I can do is, and this only works if the fraction is one that can turn into a decimal, like a friendly decimal without any repetition or anything like that. So you know, like 1/2 is 0.5, 1/4 is 0.25. I know that 3/5 is equal to 0.6. So if I was to turn 3/5 into a decimal, it would be 0.6. So what that means is I can actually take my numbers and just multiply them by 0.6 instead of multiplying by 3 over 5. So for example, if I took that 10 that I just did right now and I multiplied it by 0.6, it's going to give me 6.0, which is the same thing as 6 inches. So for this last side that I'm missing down here, the base, I'm going to multiply it by 0.6 to find my answer for the new one. So 12 times 0.6 is going to give me 7.2. So this missing part right here, because this is the base right here corresponds to this base over here, which is going to be equal to 7.2 inches. So the lengths of the other two sides for the new triangle are going to be 6 inches and 7.2 inches. These are the two solutions that we were looking for the new triangle. So moving on to our last example, example number 5. So Rob is standing next to Brianna. Rob is 6 feet tall and he casts a shadow that is 4.5 feet long. If Brianna's shadow is 4 feet long, how tall is she? So remember I told you with these problems, if you get some that don't have a picture, I like to draw the picture myself so that I know what I'm looking for. And I can also figure out basically what numbers correspond with each other. So Rob is standing next to Brianna. I know Rob is 6 feet tall, and I know he has a shadow that's 4.5 feet long. Brianna's shadow is 4 feet long. So just looking at the shadows, I can tell that Rob should be a little bit taller because his shadow is a little bit longer than hers. So I'm going to draw Rob right here. And he's casting a shadow. So I'm going to put a shadow, that's a shadow right there. And then I'm going to draw Brianna, and I know she's a little bit shorter. And she has a dress because it's a girl. And then she is casting her shadow right there. And her shadow's a little bit shorter too because she's a little bit shorter. And so now I'm going to label what I know about this. So I know Rob is 6 feet tall. So that's Rob's height. That's how tall he is. And then I know Rob's shadow down here is 4.5 feet. And then for Brianna, the only thing I know is that her shadow is 4 feet long. And I don't know how tall she is. So her height is what I'm trying to find, which is going to be my variable x. So I'm going to go ahead and set up my proportion with my 4 labels. One of them being Rob, the other one being Brianna. So Rob will be on one side, Brianna will be on the other side. And then there is 2 things that I know about these that I'm comparing. I am comparing some heights and some shadows. So those will be my other 2 labels. So height and shadow. So for Rob, what is Rob's height? 6 feet. What about Rob's shadow? 4.5 feet. And then for Brianna, what is her height? We don't know. We have the X there. But for Brianna's shadow, we have 4 feet. So I've got my proportion set up with my 4 labels. And so now I just need to try to see if I can either work within or between these numbers. So I'm looking at these numbers here and I don't know if I can really work with them. So I can either try to divide them to try to work with the ones I have now, or I can also try to simplify. And I know that if I am dividing by 1.5, I can try to simplify this by 1.5. And that's just because I know the 15 multiplications, 15, 30, 45, and 60. So I think that I can simplify by 1.5. So I'm going to use my calculator. And so I'm going to say 6 divided by 1.5. And then 4.5 divided by 1.5. So now I have 4 here and 3 here. So I no longer have this or this. And remember, I could work with the numbers that I had already and I'll still get the same answers. And then I did tell you guys when I simplify, I do like to move my fraction over here just so that I don't have so much clutter going on this side. And so this is the proportion that we are going to be working with. So I need to figure out how can I get from 3 to 4 or 3 to 4. They're basically the same thing, so I don't really have another choice. So 3 times something should give me 4. If I don't know what that is, I can take my calculator and divide them out. 4 divided by 3 is going to give me 1.3 with a repeating 3. So basically